Hello, and thank you for joining me in this presentation. So our project is predicting Airbnb prices in US cities. This project is done by Afreen, Jasleen, Nandana, Rajeshwari, and me, Ashwin. This is the outline of this presentation. Next. Airbnb is a platform that allows homeowners to put their property on rent so that guests can stay. It gives freedom to the hosts to set their own price. The pricing is important to get right as no guests might reserve an overpriced house and the host will earn less in an underpriced house. Next. The problem we are trying to solve in our project is that many Airbnb hosts don't have a metric to gauge the value of their property appropriately. Our system predicts the mean optimized price for their particular property to increase their profits. From the guest's perspective, the guests can enter all the attributes in our system would tell them if the property is overpriced or underpriced. Next. About the data set. We got our data from inside Airbnb website. Our data comprises of multiple files which when combined to form a 108 attribute data with 305,000 records. Next. To clean our data, we changed the format of several attributes, removed null and zero value attributes, dropped duplicates, and removed columns with high correlation. Next. This is the correlation matrix. As we can see, the blue columns are attributes with high correlation. These attributes were dropped after cleaning the data. There are many null values in the raw data set, hence there is a lot of incomplete data in the correlation matrix. Next. Let's look at the exploratory analysis. Here we are plotting the distribution of numerical and Boolean categories. Here we are checking if the Boolean categorical features, if it's worth to include them in the analysis or not, as we can see some have only one column, so we can drop them. Next. In this graph, we can see the increase in the number of listings in Airbnb from 2008 to 2020. As we can see, the number of listings has sharply increased from 2014 onwards. Next. These are variable plots about the data related to ratings. The majority of ratings are 9 out of 10. These are kept as separate groups, and ratings from 1 to 8 will be binded together. Next. So how long have the hosts been listing Airbnb properties in USA? According to this graph, there was a steep increase in listings since 2015, after 2015, and we can see that there's a high seasonality and peaks are in the summer, where hosts take advantage of high number of tourists. Next. There are various plots for the time series and its decomposition into trends, seasonal and residual on yearly basis. Next.
So here comes the descriptive analysis. Most common property and the room type. More customers are preferring room type of an entire house, and coming to the property type, it's the apartment. So the entire house is preferred by 17,000 customers, that is nearly more than 60%. So the shared rooms and hotels are very negligible. This is because the hostels and the hotels are more common, booking outside directly rather than using the Airbnb. However, we can see a good increase in the new Airbnb listing over the period 2008 to 2016, but there's a sudden decrease in 2018. This can be of many reasons, or one of them can be a security reason. In order to fix the outcomes, we need to look into the most preferred cities. These are the top 20 cities preferred by the customers. When we look into the prices, here the average price is more than $650. However, the reasonable price is around $300, which is very affordable. Are the different patterns in the growth in the number of hosts and the number of listings due to the host increasing owning multiple properties? Yes, this is the graph deals with the growth of the number of hosts owning multiple properties. There are large number of listings under single host, that is nearly 2,354 listings. However, according to the graph, no consistent upward trend is found. Average prices are increasing over the last 10 years. Here, the mean price in 2009 is nearly $123, and in 2019 it's 237, which we can see that it's an increase. In this plot, we can see the prices range from 0 to 94,016. There is a more notable drop off at points like 300, 100, 300, 3,500, and 10,000. This is a graph of median price of Airbnb accommodating different number of guests. So it's the two minimum for all the number of customers. Box plot of rating provided by the guests for each property listed by the Airbnb in the cities of United States. Most of the customers are really happy as their reviews are in between 90 to 100. It is clear that there is a deposit, security deposit for all the choices made for the room type. So it is maximum for the entire house and apartment. And this availability of rooms is nearly for 8 months.
The main question still remains is the pricing, and that's what our prediction models revolve around. The first model we have tried is linear regression. Next, assuming the variables to be linearly distributed, we plotted them against the price and selected our features for the model. Also, we have plotted the correlation matrix to see the features relation with price. And after training and testing, we get a model with an accuracy of 60.8, which is all right. Next. Here's a plot showing the comparison of actual and predicted prices of the value. Then we move on to logistic regression. Features for this model are same as linear regression, excluding the ones that introduced multicollinearity, such as bathrooms and bedrooms. The model predicts 37,368 correct predictions and 10,458 incorrect predictions. As per the ROC curve, you can see the farther the curve is from the dotted line, the better the result, which is not yet achieved in logistic regression. So we tried to better our prediction model using random forest, as it is a better algorithm to deal with hyperparameters as in our case. With keeping the same features intact, accuracy improves to 87% and with a much better ROC curve. This tells us that at best, the model was only able to explain 87% of the variations in price. The rest is probably made up of features that are not present in the data. Next.
So now, in order to predict the prices more accurately in our project, the dataset needs to be clean. But like even after processing, cleaning, and doing everything with the data, there are some data points left in the dataset that deviates way more from the average. These data points are called outliers or anomalies. For the accuracy of the models, these outliers needs to be removed from our data sets. Now, by looking at the graphs and observing it, we can observe that some data points are way far from the average data points, and these points can be considered anomalies and needs to be removed from our data. Next. In order to do so, we have implemented support vector machine method, SVM. This is an unsupervised machine learning algorithm that can be used to flag the anomalies. This method has been used, the attributes such as number of bathrooms, beds, houses, and accommodates the size of the house to find the outliers in our data set. So based on looking at this graph, we can see that the outliers has been flagged as in red color, and the other non-outliers has been colored blue. Next. Now we'll move on to prescriptive analysis. Next. After implementing prediction analysis, there was still scope of improvement, so we can augment the model with natural language processing, and we can also include a wider geographic area, such as more US cities. Next. Conclusively, for our user to be more interactive with our model and with our project, we create an interface in which any customer can put the features that he wants to and can get the price for his accommodation. Next. These are the references that we have included in our data set. Next, thank you for your time and consideration.